The circle C has centre -2, -1 and passes through the point 3, 1. So we want to draw this circle. So we plot the centre and we plot this point on the circle, 3, 1. Put a compass point here, set it to this distance and draw the circle. The centre is called HK. Find the radius of C and hence write down its equation. So the circle is called C. The radius of C is of course this distance here, the distance from the centre to any point on the circle. So how do we get this distance? Well, we could use the distance formula. We could call one of these points x1, y1 and the other one x2, y2. Plug the values into the distance formula and work out the distance. The way I will do this is just to use the diagram and look at this right angle triangle. I'm going to get x2 minus x1, which is actually just a horizontal distance between the points, and then I'll get y2 minus y1, which is the vertical distance between the points. So really what I'm doing is just using the distance formula, but I'm just using the diagram to work out x2 minus x1 and y2 minus y1. Anyway, the horizontal distance between these 2 points, if you just count the units here, is 5. And the vertical distance, if you count the units, is 2. So now we can just apply Pythagoras' theorem. R is the square root of the sum of the squares of the 2 short sides of this right angle triangle. So we square 5, square 2, get the sum, and then get the square root. 5 squared is 25, 2 squared is 4, we get root 29. Now we need to get the equation of this circle. So you just look up the equation of a circle formula, and just plug in all the values. The centre of the circle is -2, -1, so this is labelled HK. So we need the centre and the radius to specify a circle. So we just plug the values in here. So we've x minus -2 squared, that's x plus 2 squared, plus y minus -1, that's y plus 1 squared, equals r squared. Well, root 29 squared is just 29. So this is the equation of the circle. So any point on the circle will satisfy this equation. So for example, if we look at the point 3, 1, and plug 3 in for x and 1 in for y and work out all of this, we will get 29. R is the point 1, 6. By finding the slopes of PQ and QR, show that QR is a tangent to C. Let's look at the point 1, 6 on this diagram. Go out 1 on the x-axis, up 6 on the y-axis. So here is point R. Now we want to show that QR is a tangent to this circle. Well, if you draw a line from R to Q and continue it on, you will see that it certainly looks like a tangent to the circle. It certainly only appears to cut the circle at one point, at the point 3, 1. It doesn't appear to touch the circle at any other point. But that's just from drawing. How do we actually prove that it definitely is a tangent to the circle? Well, we have to consider the slopes, as the question suggests. We get the slope of PQ, and then we get the slope of QR. If the lines are perpendicular, then the slopes are inverses of each other. Well, the slope of PQ is got by taking the rise and dividing by the run. And PQ has positive slope because the line is going in this direction. Of course, you can also use your formula, y2 minus y1 over x2 minus x1. Plug these 2 points in. Let's look at the slope of RQ, or QR. Well, we can use the diagram to get that. It's quite straightforward to use the diagram using these 2 points to get the slope of this line. Go across 2 units. You see that we have to go down 5 units to meet the line. So this distance here is 2 and the distance down is 5. So the slope of this line is rise over run, 5 over 2. But of course, since we're going down, the slope is negative. This line has a negative slope. Because if we go out a certain distance from any point on the line, if we increase x by a certain amount, we have to decrease y to meet the line. Of course, the other way to get the slope is just to use your formula. And if you use your formula, you'll get -5 halves. Now we see that if we take 2/5 and multiply by -5/2, we get -1. If the product of the slopes is -1, it means that PQ is perpendicular to QR. Now, since a tangent is perpendicular to the radius to the point of contact, we know that this line QR is a tangent.